So we're back. We're going to take a look at another couple problems here from our worksheet. In this number 26, we are looking at this circle, angle DOE. The central angle is 150. OE is 2 root 3. What is the exact area of the shaded region? Okay, well, let's see. The exact area of the shaded region is the area of a sector. The area of the sector, okay, is sector area is, okay, the angle, which is 150 over 360 times pi r squared, which is OE, which is 2 root 3 squared, okay? 150 over 360 should simplify to 5/12, I believe, by dividing both by 30. Pi, 2 root 3 squared, put it over here, 2 root 3 squared is 2 root 3 times 2 root 3, which is 4 root 9, which is 4 times 3 for 12. 4 times 3, which equals 12. So it's 5/12 of 12 pi. So it looks like we'll lose our 12s and get 5 pi as our area. Okay. In number 29, what we're looking at is that small little cap. Well, that's actually what we don't want. So we can reason out. Let's find that and subtract it from the entire circle. Okay, that might be the easier way to go. Okay, so I'm going to find this little piece of that's missing. I know that the entire circle, let's put it this way, the entire circle minus the that little cap is what we call the segment. So the entire circle is, of course, a circle of radius 8, which makes that 64 pi. Now, okay, how do we find that little segment? Well, we know that that's a 60-degree angle right there. There's our 60-degree angle. So that whole region in here is what? Okay, 1/6. That's 1/6. 1/6, or 60 over 360. It's 1/6 of the area of the circle, which is 8 pi, 64 pi, 8 squared pi. Okay, so that's 1/6 of 64 pi minus, okay, minus this triangle in here. Okay, so we got to look at that triangle in there. Now, what is that triangle? That's an equilateral triangle. It's an equilateral triangle. The sides of the equilateral triangle are what? 6, because that's the radius, 6. The equilateral triangle is split into, okay, a 30, 60, 90. This side here is 6. This side here is 3. The height would be 3 root of 3, right? It's the short leg times root 3. So it's minus, okay, minus the half of the height, which is 3 root 3, times the base, which is 6, okay, times 6. So I'm going to leave you to clean that up, but I mean, it's not so hard to see that, you know, this is essentially 6/6 of 64 pi. So I'm basically having 5/6 of 64 pi, all right, minus a minus, which makes it plus. 1/2 here makes that 1/2 of 3 times 6 times root 3, so that would be 9 root 3, 9 root 3. So that would be my area in question there, okay? Number 33, the shaded area is 64 pi centimeters cubed. That's these little caps right here. All of them are 64, which means any one of them is 16 pi. Find the radius to the nearest tenth. So it's kind of coming back to this, okay? What I know here is I've identified the shaded region as 64 the sector, the segment, which is equal to the sector minus the triangle, okay, is how we're going to find that. Now the segment is 1/4 of this entire area, okay? 1/4 of that entire area, which is going to be 1/4 of 64 pi, which is 16 pi. 16 pi is that segment. The sector, which would be the quarter of a circle minus the triangle, would be, okay, 1/4 of, okay, pi r squared, okay, minus, okay, the triangle, which would be 1/2 r times I, or 1/2 r squared. 1/2 r squared, okay? So how do we proceed to find this? Okay, well, let's see. We have r squared over here. What we've got is a common factor, r squared, which can be factored out. R squared gives us 1/4 of pi, okay, minus 1/2, all right, is equal to 16 pi. So now we can simply put that together, and you can take out your calculator, and you can see that if I divide everybody by this and take the square root, r is going to equal the square root of 16 pi divided by, okay, 1/4 pi, so we'll just put it as 0.25 pi minus 0.5. Okay, so you just got to do that little calculation, and that will give you the value of r. And lastly, let's take a look at this. Okay, you had a problem before then, which was to find the entire shaded area. Okay, so the entire shaded area, which is the area between the two circles from problem number 34, that entire shaded area would be, okay, pi big R squared minus pi little r squared. I guess I should make that little r. But really what I want is 1/4 of that, because I only want a 90-degree slice of that. So that would be 1/4. So that would be 1/4 of big R squared is 12, so it's 144 pi minus the smaller, which is what, 81/9 squared, so it's 81 pi. Okay, so there you have it. Okay, which is give us what, 19, so I guess that's 63, 63, 1/4 of 63 pi. Yeah, 63 pi. That's 144. So it's 44/19, and so 63 pi. Yeah, 1/4 of 63 pi, or 63 pi over 4, which would be the area of that. Okay, so there you have it. All right, some of your favorite, some of my favorite, maybe some of your least favorite problems, but there they are, done up for you. And you just don't know. You might see some of those on the upcoming test. So get ready. Okay, and there we have it.